We all know that the computer gets faster when the chips get more powerful. So there is like much faster processors, more clock speed, and much more cooling effects. But then I started learning about GPUs. So that's when it hit me. It's not about the chips getting faster, and we had to think in a different way. Uh, the GPUs are not that faster because they are stronger. They are faster because they do analyze these problems in a really different way. It's a simple but a powerful way of doing things. Like you might know, a normal computer solves the issues very fast in a sequential manner. It solves one problem after the other. But a GPU solves many small things at the same time. It doesn't think smarter. It doesn't do things faster. It just do the things in a wider way. That simple idea, doing many things in parallel, completely changed how I approach the problems. Uh, for instance, we can correlate this into a real life world where we can imagine a CPU, that is like a specialized chef, who is about to create thousand of dishes for you or your friends. So what does he do is like create one dish after the other. He's a very specialized chef, so he can do it in a really fast way. But imagine instead of one specialized chef, you have like thousands of newbie chefs who are given these thousand recipes in parallel, and they will also create the thousand dishes for you. Who will be able to complete it faster? Who will be able to give you those dishes in a much more smoother or a faster way? This is how GPUs work. GPU doesn't race through one recipe, it divides the recipes into tiny steps and spreads them across these thousands of kernels or thousands of workers. That's why GPUs power gaming, video editing, AI training, and many scientific simulations. They process millions of data pieces in parallel. It's not about one person doing steps sequentially in a faster way. It's about thousand people working together, making it much more faster. So what are kernels? This can be correlated to the recipe card that we give to the chef. This kernel is not something that we learn in convolutional neural network. These are like really different, but it's not that complicated either. So we can think of kernels as like small instructions that you give to the worker. So a kernel is a tiny program or set of instructions that tells the small processor in the GPU to what to do. So you can tell one processor or a worker in the GPU to add two numbers. So that's the basic instruction that you can give in the kernel. So GPU sends that same instruction to thousands of workers at once. So each worker follow the same recipe but different ingredients or different values. You can add multiple numbers with the same operation addition, and this will give you thousands of results altogether, and this can be taken out and given as the output. So a single kernel, it has one instruction. It is distributed about around 1000 crores, and this will be executed parallelly, and it all happens together. So that's where you get the faster results, and that's the real power of GPU computing. Not just one complex job, but many simple jobs done uh, together. So how will this change how you think about the GPU? So when you start installing CUDA, checking the system recognition, and running the first-hand kernel, it will just look like another program. It will just show one or two lines of output. But now then you have to analyze how much of these cores have been used. Like it could be 20% of the cores or 30% of the core. The more core you utilize, the better your programming methodology is. So these tools just does not help the computer, but it also changes how you think about programs. Earlier, I used to think that okay, you can make this program much more efficient just by using different algorithms like faster methods. But here, it's altogether a different terminology for me, because here it's not about analyzing and finding a better algorithm, but dividing that high complex algorithm into a smaller one, so that I can uh, allocate those tasks or delegate those tasks into smaller kernels in a faster approach and combine them together to solve the larger complex problem. So the code isn't uh, now the code is not one it's not done sequentially. It's not like doing this thing after the other thing and the other thing. It's not like that anymore. It's more like doing everything together and combine the results together so that we get the final output. Now you can also visualize this results and get an analysis based on that, so that you can improve the results that you get from the GPUs as well. So it's not about getting the right outputs. It's always about getting the right outputs, but getting the right outputs in a faster way. So you will analyze, okay, what all the things you can do, how would you can divide the complex problem into a simpler ones, and how much more efficient or how much more cores you can use. So that's where the approach to the programming changes when you are doing in a GPU environment. So here it's now you will realize that how much structure and little cores you need. It's not about chaos, it's about organized teamwork inside the machine, and that's something really different, and it's a great lesson for every engineer. Like I said, the first problem usually will be a really small one. You can just try adding two numbers using Numba for Python. It's really simple. Uh, it's about how much cores you use and nothing more. It's really simple. It's that aha moment that you get while you do that. It's the result might be, you might think, okay, this is just another addition of two numbers, but what is happening behind is the real fun. You are defining a vector, and these vectors are spread across multiple cores, and it's not looping through each number. It's adding the values in the cores at the same time, and this makes the difference. Like, you are not looping from one value in the vector to other. You just add all the vector together as an it's just like adding two numbers. Adding two vectors becomes equivalent to adding two numbers in GPU. So the speed is like exponential. It's really instrumental. You can just see how faster the GPU cores, and it's just doing a really simple task. Now then you start to think, okay, it's not about finding the complex algorithm to solve this issue. It's just how easier we can make, so that we can parallelize or delegate these tasks to smaller uh, cores, so that the problem is solved in a much faster way. It's not in the single parts, but in patterns. It's a mindset shift. So yeah. Then learning about GPUs taught me that more than computer science, it taught me how to think wider, how to break small problems into smaller parallel parts and design things at code. So for if you're thinking about learning about GPU coding, I will definitely suggest you to break down the complex problem into small parts. Design it for scale, like the solutions that needs to grow, adapt, not work once. Then, like everybody else, I am also learning this stuff. I am not an expert in any matter, so I am making my own mistakes even in this video as well. But over the time, as I learn more, but with each problem I face, each challenges I finish, I am also gonna share my path, learning stuff. It might seem relevant for you, like I am touching on various things, but for me, it's just fumbling forward, learning new stuff, improving one step at a time. It could be robotics, it could be AI, it could be CUDA. For me, everything is stitched together, making a better person, a better engineer. So if you want to follow my journey, learning more about engineering and technical stuff, you can just follow to my channel, subscribe to my channel, and that's all. Bye.